Welcome. Thus far we have seen what is a derivative, what is the definition of derivative, and the relationship between the definition of derivative and this expression. So to give continuity to the study of derivatives, we are going to see an example of not to solve, not to find the derivative of a function, but rather an example to use what we know of derivative of a function. So this is more clear when we study about the equation of a line which is tangent to a graph, because to find this equation of a line we forcefully have to find the derivative of a function. So we consider the function f of x is equal to 3x squared plus 1 at a point x is equal to 2, and we have to show it graphically. So let's start. So they want us to find the equation of the line tangent, which means this line is a tangent to the graph of this function. And to find the line which is tangent, the equation of a line which is tangent to a graph is given by y minus y1 is equal to f dash of x into x minus x1. So as we've been saying, the slope was also given by f dash of x, which was the rate of change of a function with respect to a variable, and then this was the definition, and this is the relationship, the expression that has a relationship with the definition, and both give the same value. So this implies that for us to find this equation, we have forcefully to find this f dash of x. So our function is f of x is equal to 3x squared plus 1, and our x1 is equal to 2. So to solve this thing, we have two possibilities, where we can just go ahead and solve using the definition, or we can also use this expression that has relationship with the definition. Both ways are going to give us the same result. But because in the last video we just saw the relationship of this function with the definition, I think we can go with this expression here, so we can get more acquainted using it. So first we need to find f dash of x. We have f dash of x is equal to limit when x tends to x1 of f of x minus f of x1 divided by x minus x1. So our x1 is 2, so we have limit when x tends to 2 of f of x, the function without any modification, 3x squared plus 1 minus f of x1, the function wherever we have x we replace by x1, which is 2. So we have 3 into 2 squared plus 1. All this is divided by x minus 2. See, we cannot replace this x here by 2 because we're going to have division by 0. So we have to try to operate it as smooth as possible so we don't have these problems of division by 0, which it's not allowed in maths because there's no division. So we come with limit when x tends to 2 of 3x squared plus 1 minus, this is 4, 12 plus 1 plus 13 divided by x minus 2, which can also be said as limit of x tending to 2 of 3x squared minus 12 divided by x minus 2. So we need a way to simplify this, and we have to operate using the numerator. So this is a case of x is equal to plus or minus 2, which is the root of 4. So this becomes x minus 2 x plus 2. So what we have here, we have limit of x when tends to 2 of 3 into x minus 2 x plus 2 divided by x minus 2. Now we can simplify this, and as we simplify, now we can just replace wherever we have x with 2, and because now we are replacing, we don't need to write limit again. So we have 3 into, in place of x we put 2, 2 plus 2, which is 4 into 3, 12. So the derivative of this function f of x 3x squared plus 1 at the point x is equal to 2 is equal to 12. So now we need to come back to the required equation. So y is equal to f dash of x into x minus x1 plus y1. We are taking this y1 and putting the other side. When this comes with the other side, the signal becomes plus. So this is x1. What is our x1? Well, our x1 is 2. And what is our y1? Our y1 is this equation f of x squared when our value of x is 2. So this thing, which is f of x1, is equal to, wherever in this function we have x, we replace by x1, which is 2. So we can see that y1, which is f of x1, is equal to 3 into x squared is 2. 2 squared plus 1. So this gives what? This is 4, 12, 13. 13. So our y1 is equal to 13. Now we can have our equation as y is equal to f dash is 12 into x minus x1 is 2 plus y1, which is 13. So we can try to make it more beautiful than this. This is the required function, or is the required equation. This is the required equation that the example asks. But the example also asks to show it graphically, so we have to draw a graph of this function, while we have in the same plot the graph of this function, which will be the tangent representing a line. So because this is a quadratic equation, we have f of x is equal to ax squared plus bx plus c. This is the general formula. This is the general formula of a quadratic equation. So what we have here is a quadratic equation. When we have a quadratic equation, we need to find the coordinates of the vertex, and then we have to know whether the function is convex or concave. To find whether the function is convex or concave, we have to find what are the value of these coefficients a, b, and c. In our given function, f of x is equal to 3x squared plus 1, our a is 3, our b is 0, our c is 1. So a is greater than 0. When a is greater than 0, which means it's something like this. If a was less than 0, it would be something like this, which is concave, and this is called convex. So knowing now that we have a graph of a convex function, we need to find the coordinates of the vertex. So to find the coordinates of the vertex, we have they express it as x vertex, y vertex. So to find x vertex, which is the coordinate of x of the vertex, and y in the y-axis and of the vertex, we have these formulas. X vertex is equal to minus b divided by 2a. Our b is 0, so this is 0 divided by 2a, which is 0. Our y vertex is equal to minus delta divided by 4a. So this is equal to minus delta divided by 4 into 3. But we don't have delta. So we know that delta is equal to b squared minus 4ac. So this is equal to minus 12. So y vertex is equal to minus 12 divided by 12. and this is 1. So the coordinates of the vertex are 0, 1. Now we need to find how will be the graph of the tangent line. A tangent line is a line that, because this function is not a constant function, what happens that anytime it is going to cross the two axes, it will cross the x-axis at a point and the y-axis at a point. So because it's a line, if we can find these 2 points, we can just draw a straight line and it's going to represent our tangent line. So to do so is to find the point at which this function intersects y is a point at which x is 0. So the function is y is equal to 12x minus 1. 12x minus 11, sorry. So this function is going to pass at 2 possible points of intersection with the axis. At one point, x is going to be equal to 0. So y, when x is 0, is equal to minus 11. And at the other point, the value of y itself is going to be 0. So what we shall have is 0 is equal to 12x minus 11, meaning that 11 is equal to 12x. So we can say that x is equal to 11 by 12. So our graph of the tangent is going to pass through these 2 points. One point is equal to 0 minus 11, and the other point is 11 by 12 and 0. So now we have to represent, we have 2 points. As we said, one, x is 0 and y is minus 11. We can consider this point here as being minus 11, y is minus 11, x is 0, and the other point, x is 11 by 12, which we have, let us say this point is 1, so this will be somewhere around here. This is the point 11 by 12. And we know that our first function has the coordinates of the vertex as 0 and 1. So 0 is x, which is from this point, and y 1. We can consider this part. So we have, this is the tangent of x and this is our f of x, and this is the point at which these two graphs touch each other. This is x is equal to 2. This is 13. So this is the point at which the functions, the graphs touch each other. Tangent touch the graph of the function f of x, and thus the exercise is solved.